In this experiment, we shall learn how heat transfer rate goes down when the temperature rises, how to manipulate functions on our experiment results, and how to run offline experiment. We shall use the NeuLog USB Bluetooth module and the temperature logger sensor. The Bluetooth module has an ID number and 2,300 mAh battery. Connect the logger temperature sensor to the BLT module. Turn on the BLT module by pressing the button on the module panel. The left LED blinks with blue and orange colors, waiting for communication. Click on NeuLog application icon to load the software and to run it. The software automatically identifies which sensors are connected to the computer. The sensors are sampled every 1 second and displayed. The BLT LED turns on with color according to the computer platform. Each sensor has a determined ID number 1 to 9. This enables us to use up to 9 sensors of the same type in an experiment. Click on the Run Experiment button to open the Experiment Setup Parameters window. Set the experiment for 10 seconds duration at 50 samples per second with trigger level of 32 Celsius degrees. The Record button sends the setup parameters to the sensors. The screen shows that the sensor is waiting for trigger level of 32 Celsius degrees. Put the temperature probe into the hot water. Sampling and displaying are done when the temperature is above the trigger level. The graph with the results will display now. The sensor image on the left shows the participant's sensor in the experiment. Change the graph color to blue. The double arrows button switches to live screen and back. We can view the samples in a table, the graph in dots, and back to graph display. We can view the measurements before the trigger level. We can export the experiment and save it as CSV file, mail it, print the graph, or save the experiment setup. We can freeze the graph and run another experiment so that we will see the 2 graphs on the same screen. We can exit and leave the graphs. We can open the saved experiment. We can zoom fit the graph. Clicking on the icon on the left displays the graph parameters: maximum, minimum, average, standard deviation, and the graph area. We can add cursors and move them. The X and Y values of the cursors are displayed on the left. We can check the gradient of the graph with the linear fit, one of the 22 functions of the software. We can see here the equation of the linear fit line. The gradient of the line is 4.99. We can check the gradient of the graph also at the end of the experiment. The heating rate varies according to the difference between the hot water temperature and the probe temperature. The difference decreases all the time, and as does the rate accordingly. The gradient of the line is 0.37. The rate at the beginning is 10 times than at the end. Zoom fit helps us to see how the heating rate goes down while the temperature rises. Return to the main screen. For offline experiment, click on the sensor image to see the sensor parameters in its flash memory. Check that the duration is 10 seconds, sampling rate is 50 per second, and trigger level is 32 Celsius degrees. When changing value, the button color is changed to orange until we click on it and the sensor is updated. Turn off the BLT module by pressing its orange button for 5 seconds. Now the BLT module acts only as a battery module. Press the Start/Stop button on the sensor panel. The LED on the sensor blinks to indicate waiting for trigger. Put the temperature probe into hot water. When the temperature is above 32 Celsius degrees, the LED stops blinking and then turns on for 10 seconds to indicate experiment running. Turn on the BLT and wait until the NeuLog software identifies it. Click on the Load Experiment button. The open window shows the save experiments up to 5 in the sensor's flash memory. Click on the orange button and the saved experiment is loaded and displayed. We can freeze the graph and load another experiment. We can export and analyze the experiment as we did online. Challenge. Run a 10 seconds experiment with a trigger lever of 50 Celsius degrees. Put the probe in hot water and then in cold water. Check the cooling rate at the beginning and at the end of the experiment. With only one USB Bluetooth module, any set of sensors can be connected to any computer platform. Single wireless communication channel. Only one very high-capacity battery to recharge. A single free software for all computer platforms.